It is known that initially, serverless architecture referred to the combination of FaaS and BaaS. With the growing acceptance of long-run mode by developers, the definition of serverless architecture has naturally been upgraded. For example, serverless should be FaaS plus BaaS plus CaaS, or FaaS plus BaaS plus others, or simply server plus less, which means serverless architecture is a form of server-side free operation and maintenance, or low operation and maintenance. So, what exactly is the architecture pattern of serverless, and how to go about selecting serverless technology? Hello and welcome to this episode of Cloud Forward. Today, let me introduce you common architecture patterns for serverless. Currently, the boundary of serverless is somewhat ambiguous, and many cloud services are evolving towards serverless. Today, we will explore how to use serverless architecture to support these scenarios from a business perspective. Let's start by looking at the scenario of static website. If you choose to buy a server directly or purchase a cloud server from a cloud vendor to run your website, there are complex operation and maintenance issues, such as budgeting, scalability, and being able to achieve high availability and self-monitoring. If you use serverless architecture to build a static website, it can be directly supported by an object storage service such as OSS, and it uses CDN to retrieve content from OSS. This has advantages in terms of operability, scalability, cost, and security that other solutions cannot match. Let's now consider the scenario of a dynamic website. For example, how to dynamically return results based on user requests for a product page on Taobao. Common solutions are web monolithic applications and microservice applications. Regardless of which architecture is chosen, serverless helps us focus on our business. Serverless microservice architecture introduces API gateways, function compute, or Serverless App Engine to implement the computing, offloading a lot of work to cloud services and allowing users to focus on implementing business logic. The interaction between multiple microservices within the system is achieved by providing an aggregated service for products, which presents multiple internal microservices to the outside uniformly. These microservices can be implemented through Serverless App Engine, SAE, or functions. This architecture can also be further expanded to support access by different clients. The dynamic page generation we mentioned earlier is completed through synchronous requests. Other common scenario involves requests that typically require more time or resources to process, such as managing image and video content in user comments. This involves how to upload images and process them, thumbnailing, watermarking, censorship, etc., and videos to meet the playback needs of different clients. How can we perform real-time processing on uploaded multimedia files? The technology architecture for this scenario has gone through evolution of server-based monolithic architecture, server-based microservices architecture, and serverless architecture. Server-based monolithic architecture faces some issues, such as limited space on single server, the need to purchase more servers, and whether web application servers are suitable for CPU-intensive tasks. This server-based microservice architecture solved most of the above problems, but still faced some challenges, such as how to manage the high availability and elasticity of the application servers. Serverless architecture has effectively solved all the problems mentioned above: load balancing, high availability, and elasticity of servers, and message queues that developers use to handle have all been transferred to the internal services. As the architecture evolves, we can see that developers are doing less and less. The system becomes more mature and the business becomes more focused, which greatly improving delivery speed. Let's take a look at a core scenario in e-commerce and order process. This scenario involves multiple distributed problem, which is the most troublesome problem caused by the introduction of microservice architecture. A monolithic application can handle this process to some extent because it uses a single database and can maintain data consistency through database transactions. However, in reality, it is necessary to interact with some external services, and a certain mechanism is required to ensure the smooth progress and rollback of the process. A classic pattern for solving this problem in the Saga pattern, there are two different architectures for implementing this pattern. One approach is to use an event-driven pattern to drive the process. The problem with this approach is that as the process becomes longer and more complex, the system becomes harder to maintain. Another architecture is Saga pattern based on the workflow. This approach brings challenges such as the need to write a lot of code to implement orchestration logic, state maintenance, error retry, etc. And these implementations are difficult to be reused by other applications. In this case, we can rely on cloud services such as Alibaba Cloud Serverless workflow service to handle all of these tasks, which allows users to focus only on business logic states. We can see that this achieves the effect of the event-driven Saga pattern mentioned earlier, while greatly simplifying the process and improving observability. Let's take a look at how to select serverless technologies next. Alibaba Cloud offers serverless products for functions, applications, and containers, allowing users to choose the appropriate product based on their specific use case. Alibaba Cloud Function Compute (FC) is a FaaS, function as a service product that is event-driven and fully managed. From the user's perspectives, all they need to do is writing the code and uploading it to a function compute. At this point, there is no cost yet, and only when the function is called will there be a charge. The way to call it can be through the product's provided API, SDK, or through some event sources such as Alibaba Cloud's OSS event. For example, when a user uploads a file to a specific bucket in OSS, they want the file to be processed automatically, or they upload a zip package and want it to be automatically decompressed to another bucket. These are typical function scenarios. Let's take a look at Alibaba Cloud's Serverless App Engine, SAE, which is the industry's first serverless PaaS platform for applications. SAE provides computing resources, elasticity, and isolation capabilities from the resource level, allowing users to focus only on their applications. At the application level, SAE provides monitoring, logging, microservices governance, and other capabilities to help users address application observability and governance needs. SAE also provides network configuration and traffic control capabilities and has good integration with CI/CD, allowing users to use existing CI/CD tools such as Jenkins and Alibaba Cloud DevOps to deploy to SAE. It covers the entire process of application migration to the cloud. Next, let's learn about the leading service in the industry. Serverless container service, Alibaba Cloud Serverless Kubernetes ASK. Kubernetes operation and management are still relatively complex, and the skill requirements are high. Is there a solution that allows users to enjoy the container orchestration capabilities provided by Kubernetes without having to worry about the operation management and elasticity issues of ECS and Kubernetes? This is the solution of the serverless Kubernetes. The corresponding product in Alibaba Cloud is Alibaba Cloud Serverless Kubernetes. In the ASK solution, users create an ASK cluster without specifying any ECS nodes and then deploy images through standard Kubernetes container orchestration, such as deployment. ASK will automatically build the required pods in the underlying resource pool and perform elastic scaling based on the user's load requirements. Users no longer need to worry about capacity planning, ECS machine maintenance, resource limitations, and other S-level issues, which is very convenient. If you are keen to know more about Alibaba Cloud Serverless, click in the description below. And don't forget to subscribe to this channel for more videos of Cloud Forward in the future. Until next time.